I'm going to teach you everything you need to know about accounts on Solana in this video. I'll start by explaining what accounts are, the different types. I'll show you everything you'll find inside these accounts and what everything in there is for. I'll end with a bit of code that shows you how you can make accounts and how you can read accounts. Solana is a global computer, and everything on this global computer is stored inside accounts. Accounts have labels called addresses that let us identify them. So this right here, I've got 3 accounts. The green account takes up more space on the Solana blockchain because it has more data on it. No matter what you're thinking of, no matter what you know of on Solana, everything on Solana is stored inside accounts. Program data, program code, wallet data, NFT data, token data, everything on Solana exists inside accounts. There's 3 different types of accounts on Solana: program accounts, data accounts, and user accounts. If you've got a wallet like Phantom or Backpack, you have a user account. This stores your user assets like Sol, and it's controlled by a wallet, and it links to all the other accounts that store your stuff. So if you have tokens, for instance, in that wallet, those tokens have their own accounts, and I'll get to that later. But yeah, the first type is a user account, and that is probably what you have. If you've got tokens, you have a data account. So data accounts are accounts that store data from programs. So Solana programs themselves, they don't store any data, and all the data for those programs is stored inside data accounts. And that's what data accounts are. No matter what data is being stored, such as let's say token count, that's stored inside data accounts. Finally, you've got program accounts, and these are the accounts that store the actual programs themselves. They only store program code, they don't store anything else, and they store it in the format of compiled bytecode. And I'll explain what this is later as well. But yeah, these are the 3 major types of Solana accounts. You might see things like native accounts. Native accounts are just accounts that are for system programs. You might see a bunch of labels like PDAs. They are a type of data accounts, but generally these are the 3 major types, and everything else falls under them or is just another name for one of these accounts. Let's take a look at what's actually inside these accounts. All accounts on Solana have these 5 fields: owner, executable, rent epoch, lampworks, and data. So all accounts on Solana are usually owned by another program. It's either a system program or a user program. It is possible for accounts to be owned by user accounts, so your wallet could own an account, but that usually doesn't make sense, and there's no reason for that to happen. So almost always, accounts will be either owned by a system program or a user program. If you've got a wallet like Phantom or Backpack, your account it's probably owned by the system program, which is this thing right here. It's 11111. This is a native program that owns by default all accounts on Solana, and ownership of accounts on Solana means whoever owns that account, they control what happens to that account, they control the data in that account, and the system program by default is the one that creates account and owns all accounts, and also allows you to change the ownership of an account. So when an account is first created, you can assign the ownership to another account or another program later on. Executable. This is a Boolean value that tells you whether or not that account stores code. So accounts can either be executable, true, or non-executable, which is false. And if an account is executable, that means that account stores compiled code. So the Rust code that was deployed to the chain gets compiled into bytecode, and that is stored in an account. Accounts on Solana, program accounts on Solana, do not store state, so it only stores code, nothing else. It's similar to functional programming, where only the functions are stored in the actual program account, and everything else is stored in non-executable accounts called data accounts. That's what the executable field tells you. Next up, rent epoch. To explain rent epoch and this data type, I need to first explain what rent is, then I need to explain what an epoch is, and then I need to explain how those two come together. So let's do that. The first thing you need to know is that storing data on Solana costs Sol tokens based on the amount of data. So when you create an account, you can choose how much space to allocate to that account, and based on how much space you allocate to that account, you need to pay a certain amount of Sol. So it costs you money to store data on Sol. This is because the computers that are running the Solana network, they have SSDs and they have hardware that they need to pay for. To pay them for their hardware, you need to pay them in Sol. So that's what Solana, that's what costs are. Now, when you create an account, all you're doing is you're adding rent so that then the network tracks it. And again, the amount of rent you pay or the amount of Sol you pay is based on the amount of data in there. You can calculate this via the CLI, and there's also functions on contracts as well as with JavaScript libraries that tell you how much Sol you need to pay for the amount of data you're storing. So if you, for instance, you're storing 256 bytes, it will cost you at today's prices, it's going to cost you this much amount of Sol. to be rent exempt. Now, what does rent exemption mean? In an old design of Sol, rent would be collected every epoch, which is a period of time. Let's just say, I'll explain what epoch is later as well. But in an older design of Sol, rent would be collected every 2 weeks, or let's say, sorry, every 2 days. That is no longer possible. You no longer pay per epoch. Instead of paying for rent every 2 days, now you are required to have enough rent for 2 years. So this rent exempt amount is how much Sol it costs to store 256 bytes for 2 years. The idea is that over time, the cost of hardware and processing and computing goes down. So by allocating enough Sol for 2 years, it basically becomes free. Now, what happens is, when you make the account, you calculate how much Sol you need to deposit in there to have the account be rent exempt, and therefore rent isn't collected. Paying per epoch is no longer possible, and rent isn't collected at all. So it is possible for you to make an account, store enough with enough Sol that stores whatever amount of data you need, and then over, let's say, 6 months later, you decide, I don't need this account anymore, so you remove that Sol, and that account is destroyed, and the data in there is destroyed. Now, let's talk about an epoch. So an epoch, you can think of like a checkpoint on the blockchain. It has to do a bit with consensus, and it has to do with stake. So epochs are like checkpoints for network upgrades. So every time network clients on the network want to upgrade to a new version, they want to do new things on the epoch, on the network itself, they do it at a specific time. Stake is also paid out via epoch. So if you have staked tokens, you will be receiving new staked tokens every 2 days and 2 hours, or 2 days and 3 hours, which is the length of an epoch. If you have liquid stake tokens like LST, MSOL, BSOL, GZSOL, all of those, their values will increase after each epoch. We are currently on epoch 584. There's 1 day and 6 hours left. Right. There's also something to do with leader schedule, but it's to do with consensus, so you can forget about it. Don't worry about that one. That is epoch. So yeah, again, previously in the past, rent used to be collected per epoch if you didn't have enough rent to be rent exempt. Now this is no longer possible, and rent, you need to have, no matter what account you have, you need to have enough Sol in there to be rent exempt. That is rent. Moving on, lamports. So lamports are the smallest unit of Sol. So if 1 kg is equal to 1,000 grams, 1 Sol is equal to 1 billion lamports. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 Sol. Wait, no, well, lamports. There you go. So this is what a lamport is. This field basically tells you how much Sol is in that account. Data. So data is the actual data itself. If it is a program account, or if it's a data account, it's going to have data in there in bytes. So data in all Solana accounts is in the format of bytes. This is done via something called serialization. So let me explain what serialization is. So for Solana to be so performant as be as fast as it is, all data that's sent to the chain is converted from regular human readable data to bytecode. So this is what regular human readable data looks like, and this is what bytecode looks like. There are programs and libraries and everything that does this. You don't have to do this manually, but you do need to deserialize things when you're reading data. So when you're reading data from the blockchain, it's going to be in this format, and you're going to have to know what the format or what the layout of this is to be able to convert it back into this, which is called deserialization. If you don't know what bytecode is, it is the simplest version of machine instructions. So it runs at the kernel. So this is, the kernel is the thing that sits between the applications, or aka the software and the hardware. And yeah, bytecode runs over here. And because it runs at the kernel level, it's very performant. And that's why we need to convert things into bytecode. All right, that's everything in a Solana account. Now, let me show you a few examples of this. So I'm going to show you 3 examples. First, I'm going to show you a user account. Then I'm going to show you a program account. And finally, I'll end with a data account, which is a PDA. And I'll explain what a PDA is later. If you have the Solana CLI installed, you can simply use the Solana account command, and you can put in an account address, and that will tell you what's in that account. Right here, I've got a user account, and we can see this is not executable, and it does not have any data because all it has is Sol, and it's controlled by a wallet, hopefully. Now let's look at a program account. So if I do the exact same thing for Solana account paste, you'll see that this is an executable account, and it is owned by the BPF loader, which again is a system program or a native program that deploys other programs. So it's a program that deploys other programs. It is executable, and this is the bytecode. This is the logic. These are the functions for the program itself. Finally, let's do the PDA. I'm going to copy this over. And you can see right here, we've got a bunch of data in here because this is a data account, and you can see it is not executable. It is owned by a program, very likely. So this is probably the address for another program. If we see it's got a very small amount of SOL, just enough to cover the rent exemption, and that's it, it's done. The one thing I will mention is rent epoch. So you'll see the rent epoch on all of these is the exact same value. And this is because this is the maximum value possible for the data format. That is the rent epoch. So if we jump back here, we'll see that rent epoch, this is in uint64, and this is the largest value possible for this data type. So if something is rent exempt, this is the rent epoch value that it's going to have. Cool. Moving on to the life cycle of an account. So this is pretty straightforward because there's not a lot of things that happen with an account. Now, to fund an account, anyone can send rent exempt SOL to it. So I'll show you how to do this. I'll show you how to do this with code in a little bit. But if you've got a wallet address, or rather an account address, not a wallet address, if you have an account address, you can send a rent exempt amount of SOL to it, and the blockchain, the validators, the network will start tracking that account. Next, if you want to add data to it, you are changing the content of that account. So you will need that account signature, or you will need the signature of the account that controls that. So you'll need the system program to sign it, or you'll need the program itself to sign it. You can do this if you have the private key. So if you have the private key of that account, you can change that account. Next up, to access it, again, you need the private key. So you need to, you don't need the private key. You need to know the format of the stored data. So again, the data is going to be stored in bytecode, and you need to know the format of this data to be able to read it. Like what are these first bytes? What's the second byte? What's the third byte? To be able to figure out how all these come together and what the format is, what the data types are, you need the account, the format of the stored data. To change data, again, same thing, you need the signature, and to withdraw all the SOL and close the account, you also need the signature. So if you withdraw all of the SOL in the account, it is destroyed. The validators no longer keep track of the data that is in the account, and it's just forgotten about. That is the life cycle of an account. Now let's look at how you can actually make an account. Right here, I've got some code from the Solana cookbook that shows you how to create an account. The first thing we need to do is calculate the space. Since we're just going to make it empty, we don't need to do that calculation. We can just say space is going to be empty. Next, we need to find out how much SOL we need for an empty account, or an account that has 0 bytes of data in it. We can use the function get minimum balance for rent exemption. This function is available inside programs as well. So if you're writing Rust, there is a similar function available that lets you calculate how much Rust you need, which is not really a function, it's a cross-program invocation. There is another program deployed on the network that calculates rent. You can call to that program, or if you're just making accounts using the front end, like here in TypeScript, you can just use the Web3.js library's connection object to find out what the amount of SOL is. Now that we've got that, we can configure the arguments for creating an actual account itself. All you need is the account that's sending the transaction. So this is from pub key. This is going to be your address. This is going to be the account we're actually creating. So the new account's public key will be this, and we're just generating this on the fly. We don't really care about it. We can use a specific key pair if you want, but we're just generating a key pair on the fly over here, and we're going to pass in the public key of that. Next, for the line ports, this is the amount of SOL we need. We're just passing in the rent exemption amount. Space, again, how much space we want that account to have. Finally, we've got the owner of the account, which is the program ID, and we're just setting the system program to be the owner itself. So we're not going to be changing the ownership. We're going to leave the ownership as the system program, and that's it. Our object is complete. We can send this off to the system program, and we can use the create account function to create our account, and that is it. Our account is created. All right, we now have an account on the blockchain that we control. If we want to add data to this account, we need the key pair. Without this key pair, we cannot access it and we cannot change it. Now, let's say someone else wants to read the data in our account. We need to give them the public key. So we need to A, keep track of the public key, and B, send everyone the public key of this account just for them to be able to read our data. Let's say we've got a game and we've got game data in here. Let's say we've got the high score for an account, high score for a video game in here. For other people to be able to see that high score, they're going to need to know where that sits, and they're going to need the public key. This is not very good design because it requires other people to keep track of these things. A, it requires us to keep track of the key pair itself that we've generated, and B, it requires people to keep track of the public key. There is a way for you to create accounts for storing data without needing a key pair, and that is called a program derived address. Now let me explain what a PDA is, how it works, and why it's helpful. First, you need to know two things. All programs have their own public and private key pairs. Every single time you deploy a program, you deploy it to an address, and that address has a private key with it. Obviously, it's a key pair, and that key pair lets you control the code of that program. And if you want to upgrade that program or you want to change it, whatever you want to do, you need that key pair. Next, you need to know that it is possible to generate public keys that don't have private keys. So Solana uses the ED25519 elliptic curve. This is a cryptographic signing algorithm to generate key pairs. You don't need to understand cryptography. You don't need to understand what these words mean. You don't even need to understand this curve. All you need to know is that it is possible to generate Solana addresses that do not have corresponding private keys. So that is a program derived address. You derive these programs with something called seeds. So you can put into values, and based on those values that you put in, you will have a you have a address generated. If it is on this curve, sometimes it's possible for that to be on this curve. You can use something called a bump to push it off the curve. I'm not going to get too much into how this function works or how bumps work because that's beyond the scope of this video. For now, just understand that a program derived address is an address that does not have a private key. Now, with a regular account that you're storing data in, you need to keep track of the key pair. So you need to have the key pair to be able to change the data in it. And you need to store the public key somewhere. If you've got the public key, if you want to change the data with your program, you need to send the program your pub keys because the program needs to know where it's sending data, right? Finally, you can actually change the data that's stored in that account without the program's approval. Why? Because it has a key pair. And if you have a key pair, you can change it around, and that is insecure. With a PDA, it's off the curve, so there is no private key, and you can't change it without getting approval from the program. So the PDA is controlled entirely by the program, and you generate or you derive the pub key with a seed. This is quite similar to a hash map. If you don't know what a hash map is, don't worry about it. This is all you have to do. So there's a function called find program address. This is available both on chain, so you can do this inside Rust smart contracts, or you can do this with TypeScript libraries or other JavaScript libraries. And this is a simple function that you pass in two or three values into. You need a program address. So this is the address of the program that's going to be owning and controlling this derived address. You need a seed. This is sort of like a key. This is the the identifier. This is simply a string. I've got high score as a string over here, and optionally you need a bump. This bump part, this is handled entirely by program, so you can kind of ignore this, and that's why I don't have this over here. So you pass the program address and you pass the seed into this, and you will get a PDA. Now that you have a PDA, you have a location where data for that account is stored. If you want to store something else, like let's say, I don't know, latest score, so this will give you a different PDA, and you can store a different value in this account for this program. Because you use this program to generate this PDA, because you use the program ID to generate this PDA, that program ID will control that PDA, and only that program ID can manage the assets or manage the things in that PDA. Now, again, this is valuable because you don't need private keys. So when you're changing data, the program can do it all by itself, and it also makes it more secure because no one else can change the data. And you get deterministic address generation. Instead of sending people the public key for, hey, if you want my high score is stored at this public key, you can just tell them, hey, my high score is with this bump with this seed, and they can. Because they know your program address, they can put in this into the function, and they'll know exactly where the high scores are scored. And if they want to see the latest score on their own program, they can do that. This also allows for trustless CPIs, which are cross-program invocations. I'll cover this shortly in a little bit. And all of this is done completely on chain, or it's done in a functional manner, and there's no loose ends over here. Once again, we've got some code from the Solana cookbook that shows us how to create a PDA. So first, we need a program address. And to do that, we're just going to use a private key. So I've got a private key that we're going to convert to a key pair. And this is the key pair for the program that we want to have this program derived address from. Now that we have the program addresses key pair or the program key pair, we can use that to find the public key. Next, we're just going to define a seed, and this is just high score because this is what I want people to be able to find it with. And then of course we've got the program ID for the system program itself. Now to derive it, all we have to do is use the create with seed function. This takes in the base public key. So this is the public key of the program or the program ID. This is the seed. This is simply a string, a word, a series of words, a phrase, whatever you want, that you're able to distinguish, that you're able to locate these things from. And then you've got the system program, which is the program that is going to be owning this, that's going to own this account. Put this all together, send create account with seed, and that's it. You have created a PDA. The last thing I want to go over is cross-program invocations. So CPIs are ways for programs to communicate with each other. If I have a token program and you have a swap program, your swap program can talk to my token program to swap tokens. That's exactly what CPIs let you do. Part of how CPIs work is using PDAs. If I give you the seed and the bump for my program's PDAs, you'll know where the data sits and you'll know where to look. A very good example of this is the token program. Associated token accounts, so these are the accounts where your tokens actually sit, are all shared. So right here is a very handy chart that you might need to spend a few minutes staring at. So this is Bob's wallet. This sits on the curve. This has a public key and a private key. Same goes with Alice, and same goes with the associated token program. So you've got a user wallet, a user account, and a program account. Next, you've got the PDAs, aka the associated token accounts. So Alice has a wallet. That wallet is used as the seed, and the program ID is the associated token, the token account program, the associated token account program, and these things are used to create the program derived address for Alice. So Alice's tokens actually sit inside this PDA. Same thing for Bob. Bob's tokens sit inside this PDA. And if Alice wants to send Bob some tokens, it will go from Alice's associated token account to Bob's associated token account. That is how PDAs help us do lots of composable stuff. Alrighty, hopefully now you've got a pretty good handle on accounts on Solana and what all these terms mean. I do want to mention that this is not meant as a development guide. There's much better resources out there. This is more of an overview. So now that you have an overview, check the description for a bunch of links that goes over everything I've talked in detail. Yeah, go out there, make something. If you want to remember all this stuff that I've just taught you, if you want to remember all this stuff that you just learned, the only way to remember it is by making something. So go out there, write some code. Good luck. All right, let's do this.